Chapter 4, 4.1, Introduction to Graph Theory and Networks. So, as it says there's a lot of terminology in this chapter, some of which will appear on your exam. So you will need to know some terms. Strongly suggest that you bust out some those index cards. Maybe put definition on one side, term on the other, or term on one side and a drawing of that term on the other. Something like that to help you get these terms down. If you do make some index cards and you want me to check them to make sure they're accurate, that's totally fine. Just bring them by. All right, here we go. I wasn't kidding about the amount of terms we have. A graph is a collection of points called vertices and the segments connecting them called edges. Well, notice we have one sentence and 3 terms. You're welcome. Christmas came early and I forgot to get my pen ready, so I'm just going to casually lean over here. I'm leaning over here. I'm still here. Hi. How you doing? Okay, good. And I got to turn and plug in my tablet. Not going to edit any of this out because that makes sense. Can't have that. Okay, I'm doing that. All right. Now I got to wait for my pen to turn on. Here's the pen. All right. I gotta pick a color. Come on. Oh. No. There it is. Okay. Let me get what color should we use? Oh no, what did I do? Okay. We'll do purple. Okay. So in the very first one, we have the graph that contains the vertices A, B, and there's a straight line segment that connects them. In the second one, we have the vertices A, B, C, D, where A is connected to B, B to C, C to D. And in the third one, notice that we have 2 vertices A and B and 2 edges. And notice the edges need not be straight line segments. They could be curved. All of that is perfectly legal. So these are 3 examples of graphs. Now, in a graph, just because 2 edges overlap, and by that I mean if you look at right here, we have the edge AC overlapping BD. Just because 2 edges overlap does not mean that there's a vertex there. So don't assume that. It'd be like if you were looking at a map, a bird's eye view looking down, a highway overpass over a road. Does that mean that the highway and the road intersect? No, that'd be terrible. So same concept here. Just because 2 edges overlap does not mean there isn't. Oh, there's a typo on the slide, which means I gotta go fix this right now. You know what? I could just do this. Does not mean there is a vertex. Mike, I already wrote that down. Well, too bad. You want to use the eraser side? That's this side. If you have one of these pens, which you might have. That's okay, though. So just because 2 edges overlap does not mean there is a vertex there. So I said it right. Just, when you type late at night, what are you going to do? Okay. Next term. A loop. A loop is an edge that begins and ends at the same vertex. You have to read carefully in this chapter. An edge. And how many edges does that imply? 1. So the graph on the left, that is an example of a loop. However, in this graph we saw before, we have A going to B, B going back to A. Notice that took 2 edges, so this is not a loop. A loop can only be 1 edge. So keep in mind, because this is going to be a problem later, a loop is 1 edge. Always, always, always. Boop. Okay. Definition of equal graphs. 2 graphs are considered equal if they have the same vertices, and these vertices are connected to each other the same way. So in our picture on the left, we have A going to B, B going to D, D going to C with a loop on C, and then C going back to A. The picture on the right is considered to be equal because A goes to B, B goes to D, D goes to C, C has a loop, and C goes back to A. So no matter how the graph is drawn, as long as it makes that pattern of what goes to what, also loops as needed, then you're good to go. So for instance, if I said that was A, B, C, D, A goes to B, B goes to D, D goes to C, C's got a loop, C goes back to A, that's now another equal graph. All those three are exactly the same. They're considered to be equal. Now, for our purposes, it may be that you want to draw the graph to make it easier to read, which we'll talk about later on in a different section. But to highlight this concept of equality, I have some images from the London Underground system. And these go back all the way to the late 1800s when the first map was coming out. So this was the very first one. And then notice how wonderfully easy that is to read. And then over time, they cleaned it up. So that one's a little bit better. A little bit better. They made the lines thinner. And then they said, you know what? It doesn't have to be exact anymore. We just need something with straighter lines. So that's where this came from. And then over time, they just cleaned it up more and more and more. So I think this is the most accurate one right now. Or I don't want to say accurate. The final version. That's a better word. Okay. So if you would, please watch the video for finding equivalent graphs, where you are given a graph and you're asked to find or make up your own graphs that are equivalent to it.